All right, so it says vector A has magnitude 59 units and direction counterclockwise from east of 14 degrees. What is the value of its x component to 1 decimal? So let's get a picture going to give ourselves some visual framework.
Is it 14 degrees?
Yes. Clockwise from east.
So
it would be going south.
yep, so here's east, right?
Counterclockwise, so it would be going northeast. Yeah.
So we've got something like that. What was the degree? 14?
14.
Just 0.0?
Yeah.
And the units of length?
59 units.
59 units. Okay, so here's our xy coordinate system, our y-axis and our x-axis. And then we've drawn a vector that fits the description given to us. And so now it wants to know what is the magnitude of the x component. So we know that diagonal vectors are tricky to work with. So usually the first thing that we do as soon as we see a diagonal vector is we split it into simpler vectors, a horizontal and a vertical vector. So this vector is really just made up of two simple vectors. A horizontal vector that goes out that much, because now it's level with the tip of the diagonal vector. And it's also made of a vertical vector that goes up that much to the point where it's level there. Does that make sense? So that's how we kind of just draw it, eyeball it, but now we get to do some math to numerically analyze it. So it specifically wants to know the x component. So if this is vector v, it would want to know v sub x is how we would write it or how we would see it on a test. So any ideas how we go about solving for v sub x?
So is that, I'm kind of confused on what the x component is. What is that exactly?
So it's just this vector here.
Okay, so could we do like something to do with like SOHCAHTOA?
Good. So we use one of our trig functions, and you mentioned SOHCAHTOA, which is a little mnemonic that helps us remember, what each one is all about. So relative to this angle, if this is our right triangle that we're looking at, what side of the triangle do we label this as?
Adjacent.
And then what side of the triangle is this?
Hypotenuse.
So which one uses adjacent and hypotenuse? Cosine. So we can say cosine of our angle, 14 degrees, is equal to adjacent, which is what we're looking for, so we can call that v sub x, over hypotenuse, which we know is 59.
Okay.
And then in order to just make it look better, we multiply the 59 over here, and we end up getting 59 times cosine of 14. Plug that into our calculator, and we'll get a number, which is the answer.
Oh, that was a lot easier than I thought.
Yeah, so the setup can be a little tricky, but once you're there, the math is pretty quick.
Okay, cool.
So 14 cosine times 59. So I got 57.2. I don't know if it's wanting you to be careful with sig figs.
It says
one
decimal
decimal place.
so that's good.
So 57.2. And then we would usually put units on it, but since they didn't give us, meters or kilometers or whatever, it's kind of just generic units. Oh, that's not degrees though. So it's like meters or something.
And then how would we solve for the y component? That would be this
Mhm.
one?
Yep. So it'd be the same process. So now, in our mind's eye, we can kind of just
okay.
pick that up and realize that that
Yeah.
distance is the exact same as that distance. So we can just treat it as the opposite side of the triangle.
Okay, cool.
So now we would use the sine function instead of the cosine function. Or we could even use, or we could even use tangent if we wanted to. But typically we stick to sine and cosine, so maybe it's good to get practice with those two. Even though tangent is totally acceptable.
So the next one is a vector has x component 11.4 and y component 11.1. What is its magnitude to the nearest tenth of a unit?
Okay, so now this is kind of just the reverse of what we just did, because before they gave us a vector and they wanted us to split it into components. Now they're giving us components and they want us to put it back into the original vector. So what was the two components that they said?
11.4 and so the x component is 11.4.
So 11.4.
Then the y component is 11.1.
Cool. So here's our two components. If we were going to draw out the vector, we'd want it to go over this much and up this much.
Okay.
So it would look like that. That's the easy part. Now we want to do some math and figure out its magnitude. So again, we say, well, if we just pick this guy up here and we move it over here, we have a right triangle. And we know the lengths of two sides of our right triangle. And we know that a squared plus b squared equals c squared in accordance with Pythagorean's theorem.
Mm-hmm.
So we can just solve for the hypotenuse using that. So we would say 11.4 squared plus 11.1 squared equals our hypotenuse squared. 15.91. Not too bad, right? And then whatever they say about sig figs, make sure to be careful
so
about that.
That would be.
So 15.9 then.